light that is emitted or absorbed in the following electronic transition in the hydrogen atom, H. And before I solve this problem, I want to make sure that I touch base with what's actually happening in the atom. In this lecture outline, our picture of the atom is a nucleus around which there are a series of orbits, and eventually we'll come to know them as orbitals, but they're a series of orbits, and in those orbits are where the electrons are. So orbits for electrons. And the lowest energy orbit is n equals 1. And then n equals 2 is the next lowest. And as you get farther away from the nucleus, the energy of the orbits becomes higher. So higher n equals higher energy orbits. And in the lecture, we developed an equation for this, and it took a little while. So the equation that I prefer to use is E equals minus 2.18 times 10 to the minus 18 joules. And then there's a z squared term, excuse me. And then there's a 1 over nf squared minus 1 over ni squared term, where these values of n are these values of n, and these are orbits in the atom for the nucleus. And in a very real way, well, I don't have 7 to 5 on here, but for this example, let's assume that an electron travels from n equals 4 to n equals 3. When it goes from n equals 4 to n equals 3, the electron will be going to a lower energy position. So n equals 4 to n equals 3. The electron will be going to a lower energy position. And that's exactly the same analogy for the ball we were talking about earlier. And when the ball went to a lower energy position, it lowered its potential energy. As the electron gets closer to the nucleus, it will be going to a lower energy position, closer to the nucleus. And what happens is, I would say the vast majority of the time, is as the electron, so the electron will be going to a lower energy position closer to the nucleus, and the energy exactly equal to the energy of this change here will be given off as a photon. So electron is going to a lower energy position closer to the nucleus, and a photon is emitted. And so what I sometimes do is, as the electron is moving down, I draw a photon with a particular wavelength being emitted. So this is my picture representation of the process. We have an atom, we have an electron in that atom. As that electron moves closer to the nucleus, a photon is emitted. And likewise, if the electron moves farther from the nucleus, it's probably because a photon is absorbed. So that's why when we talk about an electronic transition, that's the movement of the electron within the atom. And why we're calculating the energy of a photon, because a photon would then be either emitted or absorbed. And these two processes are closely related, meaning that when an electron moves either closer or farther from the nucleus, a photon is either emitted or absorbed. Okay? So that's the process for what we're doing. And now to actually solve it, so we will use this equation. We have n equals 7 will be my initial value. So I put n sub I there, and it's going to n equals 5, so that'll be my nf value. Hopefully you can see that. And now I will plug into this equation. I guess the last thing we need to know is what is Z, and Z is the number of protons. So for hydrogen, there's 1 proton. And Z equals 1. So, plugging into this equation, I get joules, I get 1 squared, 1 over 5, then the quantity 1 over 5 squared minus 1 over 7 squared. This equation is on your conversion and equation sheets. Although on the conversion and equation sheets it has 2 and 1 there. But I will update this at some point to say final and initial. And as far as calculations, so we have to do, I usually do this term first, and I would do it 5, there's my squared button, and there's my shift 1 over button, and then I subtract 7 squared 1 over, and then I take the equal sign, so now I get that this term is 0.01959. This is just 1 squared, which is 1. That's just my units, which are joules. And now I just multiply 0.01959 times this number here. Times 2.18 negative exponent 18 negative, and I get minus 4.27 times 10 to the minus 20th. And that is in units of joules. It's also units of joules per photon, because that is the energy of a photon that would be emitted. And the other set of units you will see, because an electron is moving, you will also see the units joules per electron. And I know that neither of these units per photon or per electron are in my equation. However, what we have to know for this part is that because this is the energy of a photon that is being emitted, and it is the energy of an electron that is moving in the atom. And so let's come up here. We will see that there's both the positive and the negative value number for that. And last point, so our answer is negative. And that's because as the electron moves closer to the nucleus, the energy will be negative, the energy will be emitted. So what I'd like to write right here is energy is emitted when the electron moves closer to the nucleus. Energy is emitted when the electron moves closer to the nucleus. And let's see if I can get just about all that on, because that's the end of what I'd like to present on this problem.